Hello and welcome once again to the Maths Jedi channel. This video is another video in my A-level series. This one today is on sketching cubic graphs. It's one of those topics that's quite early on in the A-level syllabus, so if you're revising now for imminent Year 12 exams, this will help you quite a bit. Or if you're new to A-level, perhaps starting in September, this will also give you a good bridging topic. If you're new to the channel for the first time, I would encourage you to look at some of the other videos on my channel, particularly those in the A-level series, and please do also take the trouble to leave a like, because that will help support the channel and help us keep going. With regards to today, I just need to crack on then and show you a little bit about cubic functions and how they work. So let's just have a look inside this PowerPoint and take a little look at how cubic functions are or represented in most questions that you come across. So you should be aware of what cubic functions are, because you've done that a little bit at GCSE. Some of the more advanced topics in GCSE do give you cubic functions to look at, but you perhaps may not be completely idealistic about how they look. So to start with, just be aware that any cubic function takes this form. So ax cubed plus bx squared plus cx plus d. It's this last number which is the y-intercept. So if that is a number there, obviously that's where the graph will intercept on the y-axis. And a little bit similar to how quadratic functions work, the first coefficient also has a meaning in terms of the orientation of the graph. We will look and see all different types of cubic graphs in the next few minutes, but these are the main sort of things that you might get in terms of positive coefficients of x cubed, and these are the graphs that you might get in terms of negative coefficients of x cubed. And be aware that you can factorize cubic graphs just like you can factorize quadratic graphs, and you usually will get something that can be written in this sort of form with roots and factors and all sorts of other things that you would get with quadratic functions also. This particular slide is more useful seeing a practical example, so I'm going to skip over it a little bit and then show you some practical examples to give you an idea about how these work. But this is critical, and in terms of understanding how cubic functions will look, you always try to find the roots of the function, and this is pretty much generally all functions really. Find the y-intercept, and then obviously look at the coefficients of x cubed to decide what kind of shape you've got. So here is the graph of x squared in general. It's a quadratic function, you'd be aware of it. And this is the cubic graph, the cubic function x cubed. Let's look at a few examples now. So I'm going to come away from this and look at a few examples. I'm going to go into the book here. I'm looking particularly at page number 62 and 63. We're going to look at exercise 4a now. So we're going to look a little bit about how these draw and just give you some pointers about how they look and how you can sketch them. So to start with, I'm going to do a question from each of these exercises, probably spend more time on some of the more difficult stuff towards the end, but really just sort of going through some of these earlier ones so you can get an idea about how these things look. So exercise 4a, section 1, first of all, these are asking you to sketch the following curves and indicate clearly the points of intersection with the axes. So I'm going to get my Word document up here, just make it a little bit smaller so we can sort of see this at the same time. We can use this as a sort of sketch pad as we're working our way through. Okay, so we get the pen up and we can have a look at this. So let's first of all look at this, we'll look at a couple of these to start with. So as with quadratics, you should be used to seeing, in this case, 3 factors rather than 2 factors. 2 factors obviously a quadratic, 3 factors will be a cubic. And then of course the roots are generated by looking at where these factors are equal to 0. So you can see here that the corresponding root for this bracket will be 3, because 3 take away 3 is 0. Corresponding root here will be 2, corresponding root here would be -1. So I always advise you start by looking at those roots and then fill out those values accordingly. So we talked about 3, we talked about 2, and we talked about -1. So I'm just sketching this for now, just a good sketch to see what's happening. Now the next thing to do is to try and understand what's happening with the shape of the graph and how it will look. Now if I multiply out these 3 brackets, I can see I'm going to get a positive x cubed coefficient, because there's no number in front of the x here that's negative, nor here, nor here. So all 3 x terms are positive. So we're going to get a positive x cubed term. So I therefore know it's going to go sort of from a wildly negative direction, sort of over here, to a positive direction over here. We can test that by putting in x large and x small. So if I put in a large value of x, let's say 100, I'm going to get 97 here, 98 there, and 101, and those three numbers multiplied would make something very positive, so up here somewhere. And again, if I made it something very negative, like minus 100, I'd get minus 103, minus 102, and then minus 99. And again, I'm going to get a negative number, but it's going to be down in here somewhere. So we can see the general shape of the graph will be something a little bit like this. Now, in terms of sketching, we are being asked to look at the points of intersection of the axes, so I'd be quite interested to see what point that is and how I find it. So again, the way to do that is just to multiply out the brackets and see what happens when you multiply out the brackets. So if I take those brackets and multiply them out, let's just make that a little bit nicer. I'm going to multiply out these brackets. I'd have, if you can see, if I take the number parts, I'd have minus 3 times minus 2 times plus 1 at the very end. So I'd get all the middle terms. You could multiply it all out, just like you did at GCSE. So multiply out 2 to get a quadratic, and then multiply that last bit. And you could find a cubic function. But you'll get a last number that is minus 3 times minus 2 times plus 1. So minus 3 times minus 2 is positive 6. And positive 6 times positive 1 is positive 6. So I know straight away that this particular intercept point here will be 6. I know it has to be 6, because that is where the graph will cut the y-axis. So that gives me, first of all the little things that I need. Gives me the symmetries, gives me the understanding about what it looks like, gives me an understanding about how it goes from something negative to something positive. It also gives me an indication about where the minimums will be later on when you start to differentiate things at upper sixth. And it gives me an understanding about where all the intercept points are on the x-axis. So it's quite a simple example to start with, but nevertheless useful to see. Moving on, let's look at one of the other ones then, a bit more harder. Let's look at F, just to give you an example a bit more tricky. So this time we've got some different features here. We've got one x term on its own. So in this example, we've got an x term on its own. So I know that that has to be a root where x is 0. So x is 0 will be a root in this example. And then where the root is going to be here will be 2, because that's where the corresponding factor will be 0. And then the corresponding factor being 0 here, it gives you me minus 1. So those are the three factors here: 0, 2, and minus 1.
The answer to your calculation is 350.
So here are the three roots here: minus 1, 0, and 2. Now again, we're going to sort of test what happens with values if I look at something positive and something negative. So if I put something positive in like 100, I'd have 100, 98, and 101. So again, something very, very positive. And again, if I had minus 100, minus 102, and then minus 99, I'd get something negative, so it's going to be down there. So I know broadly it's going in this direction. So I know it's going like this, something like that. And our y-intercept here is 0. You can see it's 0. Just as a little tester, we'll just have a look and see what this multiplies out to make the cubic, to see if you're persuaded about that y-intercept. Because in contrast to the previous question, be aware that we don't just do minus 2 times plus 1, because that wouldn't be right, because we've got this x term here on the outside. So in the previous example, we had 3 numbers to multiply. This time we don't have 3 numbers, so it's important to take that into account. Of course, we effectively have a root here. If you think of this as x as the root, we have effectively got a factor here of x plus 0 or x minus 0. So if you take the number parts, 0 times the minus 2 times the plus 1, it does make sense to make the 0. But just to reinforce what we're doing here, it would be useful to get an idea about what the cubic function is, just to persuade ourselves that we know it's happening. So again, if I multiply out these 3 terms, that would give me the corresponding cubic function. So this will be x squared minus 2x if I multiply out these 2. And then I've got x plus 1 here on the outside. So again, multiplying everything by x first of all, I'd get x cubed minus 2x squared. And then multiplying everything by the plus 1, I have plus 1x squared and then minus the 2x. So I'm left with x cubed minus x squared and then minus the 2x. So again, that is the corresponding cubic function. We'll do one more example just to give you a bit of confidence and see what's going on. We're going to do I, just to see a more difficult example. Again, similar principle. Let's look for the corresponding roots. So the roots here are, in this case, 2. This bracket will be 0 when x is going to be, so 2x minus 1 equals 0. We're going to have 2x equal to 1. x equal to a half. So I'll put that in there, and this will be x is minus a half. Okay, again, we can look at corresponding values and see what's happening to this particular graph at different points. So we're looking at a very, very positive x number. So let's look at 100 again. So 98, 200 minus 1 is 199, and then again 201. So very, very positive here. So it's going to be up here somewhere, and again correspondingly down there. So again, it gives me a shape of the graph looking something like this. Something like that. And again, we're looking at where this point is going to be crossing the y-axis. So it'd be useful for me to work on that and see where this graph is crossing the y-axis. And in a similar way to before, we can take the number parts, so the -2, the -1 and the +1, and see where it crosses the graph. So -2 times -1 is +2, and then +2 times 1 is +2 again. So this is going to be +2 here, where it crosses the y-axis. Not very good. Let's do that again. So a bit more like that. That's better. So that's +2 there, where it's going to cross the y-axis. So again, good representation of it, good understanding about what that graph looks like. Relatively simple today. So that's exercise 4A question 1. I'm going to look at question 2 now, but it's going to take me a couple of minutes to set up, so I'll join you back in a minute when I've set that up. So bear with me for a minute while I set that up. Okay, welcome back. For you, no time has passed, but obviously I've been doing some tinkering behind the scenes to get it up to here and look at this particular page, question 2, 3, 4 and so on. So we'll do a couple of these. Again, very similar concepts, but just take our way through these very carefully to understand what's going on. So we'll look at a simple example to start with. So we'll look at this one, so B. So again, looking at the corresponding roots here, the root here will be -2. And then this one is going to be 1, but it's going to be 1 twice. So we have 2 equal roots here. A bit like when you have quadratic graphs that have equal roots, we do have cubic graphs that have equal roots as well. So we have two equal roots at +1. And again, looking at something very, very positive, if we have any positive number, we're going to get a positive number here. So it's going to be up here somewhere. And if I look at any negative number here, I'm going to get a negative number, because this one will be negative at -100. So we're going to have -98 times something positive again, so it's going to be very, very much down in this region here. So we know roughly what shape it's going to be. So because we've got 2 equal roots, it's going to look a little bit like this. So it's going to go up here, it's going to hit the y-axis somewhere, it's going to come back down, and then where it's going to trough is just at the point where it's equal to 1, and then it's going to sail off back into the distance again over here. We do need to find this point, so let's have a look at that. And in a similar way to before, we've got 3 numbers here to multiply. We've got 2, -1, and then -1 again, because we've got -1 squared. So -1 times -1 is +1, and +1 times 2 is +2. So that will be where the graph cuts the y-axis. So again, goes from something negative to something positive, and that's where the graph cuts the y-axis. 2 roots in this case. There are 3 factors effectively, but 2 roots. Okay, so just be aware of that. We can say 3 roots if we count these as equal roots, of course. H will do as well. So again, this is going to be an equal root here at +1 again, similar question, and this is going to be a root at 3. So what's happening here is we've got 2 roots again, or 3 roots really, but 2 equal roots here, and we're looking at something where x is very, very large. So if we're looking at a value like 100, for example, we're going to have this being positive, and this is going to be negative, so we're going to have it down here somewhere, and then again, something negative will be up here somewhere. So we're going to have to think about how that might look. Again, we've got the equal roots at this point here. So in a sort of mirror image of the previous one, really. It's going to come up here like this. It's going to come down. It's going to trough at this point and then go up into the distance, a bit like that. We need to find this point here where it cuts the y-axis. So let's look at that. In a similar way to before, we've got -1 twice, and we've got here a number +3. So we've got these two make 1, of course, and it's going to hit at 3. So that will be the y-intercept, +3. One more to do, which is a couple more to do, which is down here on question 3 now. We'll look at factorizing equations and going back. Sometimes the factorizing is quite easy to do. In these cases, it's all quite easy to do. You just need to look at taking x out as common first of all. So if I look at a couple of examples, say for example B, I've got x cubed plus 5x squared plus 4x. If I take out x as common, I'm left with x squared plus 5x plus 4, and then you can factorise this the way you factorise quadratics at GCSE. Very easy to do in this case, plus 1 and plus 4, and that gives me my corresponding roots, because it's asking to sketch the graph. So x equals 0 will be a root, minus 1 will be a root, and then minus 4 will be a root. And again, test values to see what's going on. Something very large and positive will be up here, something very large and negative will be down there, so it will look something like this. And again, crossing at the y-intercept is going to be 0 here in this case, so very easy to do. One more to do just to show you. Be aware of difference of two squares, because that's what's going to happen here. If we take out an x as common, we're left with x squared minus 9, and this is of course difference of two squares. So then, just like in GCSE, you would have one positive square root, one negative square root, and that gives you the corresponding roots and so on. So again, roots here would be 0, 3, minus 3, and then 3. And again, testing values to see where it's going to be positive and negative, it will look something like this. Nice and symmetrical as well in this case. Question 4 we'll look at real quick. So it's asking you to sketch the curves and indicate the points of the graph where the curve crosses the axes. These are all got something in common in that they're all cubic brackets. So this is going to be triple roots here. So triple roots, obviously, where x is equal to 3. So how will that look? And again, just taking account of what this graph looks like at positive and negative values. So if I took a very positive value, like 100, how would that look? So that's going to be 97 cubed, something very large. And again, if I took something negative, something very small. So it will look something like this. It's going to be like a basic cubic graph, but it will look like that. Probably will cut the y-axis at some point, so we just double check to see where it cuts the y-axis. And how we do that, of course, is by looking at where x is 0. So we let x be 0, and we'll have minus 3 cubed. Minus 3 cubed is minus 27. So I know it's going to cut the y-axis at minus 27. So it gives you a good understanding about where the graph cuts the y-axis. All these are very similar in concept. Question 6, lastly, we'll do very quickly. So this one's looking at the graph of ax cubed plus bx squared plus 6 plus d as shown opposite, where a, b, c and d are real constants. It's interesting, you've got to work backwards. Now there are some factors here and some roots we can generate straight away. So there's roots here at minus 1, and then 2, and then 3. This generates me the factors x plus 1, x minus 2, and x minus 3. Now in this case, if these are all the factors, we could multiply these up to get my corresponding cubic functions. Let's do that really quickly. So we'd have x squared, and then minus 2x plus 1x, that's going to be minus x, and then minus 2 here. And then lastly, x minus 3. So we're making the quadratic first. Multiplying everything by x would give me x cubed minus x squared minus 2x. Multiplying everything by minus 3 would give me minus 3x squared minus 3x plus 3x3, and then plus 6 there. And then again, that would give me a version here of x cubed. Minus x squared minus 3x squared is minus 4x squared. And then minus 2x plus 3x is positive x. And then plus 6. That's the corresponding cubic expression. Now, there's a problem here, because if this is my cubic expression, the y-intercept would be 6, but it's not 6, it's 2. So we know it's a third as much. So there is actually a little condition here that we need to put, as my a coefficient can't be 1 anymore. So actually my function has to be a third as big as that. So rather than having to be x cubed minus 4x squared plus x plus 6, it has to be a third of all that we're using as my function, because I need that last intercept to be positive 2. If that's the case, a is a third, then b is minus 4 thirds, c is 1/3, and then d will be 6/3. That's 2, the 2 we wanted. So that's just an interesting example of how you can look at where a y-intercept is and start to interpret how the graph function is going to be working together. So in this case, my cubic graph is going to be corresponding to those points that you need to look at. Okay, I think that will do me for today in terms of the questions that I'm going to go through. I would encourage you to do the others. Just before I go, I will look at the answers just real quick to give you an example of how it's looking, and you can see, and hopefully you can see how these answers fall together. So just real quick, here are the answers to that previous question. So question 6, this is where they're working it all out. They are factorizing the A term first of all, using the factors. And in a similar way to what I was doing, they're looking at the third and then understanding how to get those individual coefficients from working those things out. Going back earlier, you can see all the graphs are drawn here. To be honest, all the answers are at the back of the book, so I definitely encourage you to look through those and make sure you're clear on them, and give yourself a good ability to go through these in your own time and make sure you're getting these all right, because they're very, very simple to do once you get the hang of it. Before we start cool tick graphs in the week, these are the things I would definitely recommend you practice on and make sure you've got yourself a good understanding of this topic before you move on to other things. Okay, that's all for today in terms of the lesson. So thanks for being here and look forward to seeing you soon. Take care for now. Bye bye.